Yeah, I thought I'd do a kind of a video, a quick teardown video on this Spectrum Analyzer that I've had for about 16 years or so. This was my first Spectrum Analyzer. It's an HP 853A, and it has the 8557A Spectrum Analyzer plugin. That covers 10 kilohertz to 350 megahertz, and it's been a pretty reliable Spectrum Analyzer. It's got all kinds of digital modes you can use, and you can send plots out to plotters, or you can use software to capture plots. But it takes these plugins here. They go into this cavity here, and back here is the power supply board that powers this whole plugin. We have the this is the A5 board here. This is the analog board that drives the Spectrum scope. And then here is the what did I say? A5 or A6 board. This one here is the digital board. This one here allows you to do such things as having multiple traces and saving max hold, storing views, etc., using digital averaging and comparing traces. And of course, it allows you to send information out to the plotter. Now, the issue I'm having with this unit is that when I fire it up, it will go through its test routines and run just fine. And then all of a sudden, it acts like you've just cycled the power. It will start its test routines again, and sometimes it'll even freeze in the middle of them. And you have to power cycle the unit again to get it to come back. And here lately, it's been getting so bad that the unit's basically unusable. So I thought I'd kind of give you a little tour of the inside, and I'll power it up and see if I can capture the issues that I'm having with it. Alrighty, got the unit up on its side. So now let's power it on, and maybe we'll see if it does something here. Okay, this is the issue I'm having right here. I have all this garbage that shows up on the display. And if I try to reset the unit, sometimes it works and sometimes it doesn't. Okay, it reset. Okay, now it's running. And all is well up until the point where it will rerun the self-test routines and then lock up. So what I'm going to try to do is what I've done is I've already off camera, I've gone through, tested the power supply. All the voltages are fine. I had to tweak a couple in a little bit, but I monitored the supply voltages for spikes and dips, and I couldn't see any. I also used my HP 3400A RMS voltmeter to look for noise levels there. See, it just failed. Okay, so I did capture it. But this is the issues that I've been having with it for months. And unfortunately, I'm going to have to either find another parts unit and repair this, or just completely remove the digital board, because you can remove that board and it'll just work just fine as an analog-only Spectrum Analyzer. You just won't be able to use any HPIB functionality or do any of the digital features at all. So let me turn this unit around here. And I'll show you kind of the underside of it. This is what I thought originally was the problem, was the main CPU board, but I swapped it out with a with a known good one, and I still had that same issue. So I basically tracked the problem down to the A5 board, which is this board here. This is the board that allows you to use all the buttons on the front. This one here is strictly analog. It's the amplifier board that drives the X, Y, and Z axes on this CRT. And I checked for grins. I also checked the power supply. This power supply for the module. This supplies all the power for the module. And of course, this one up here supplies all the voltages to these two boards here. Supplies the voltages to the main CPU board, and it also supplies the voltage to the CRT. And then there's another high voltage power supply in here that's for the accelerating voltage for the tube. But anyway, let's turn this thing off, and I'll yank this card out. Well, so here are some kind of close-ups that of the module here. Like I said, this module focus covers 10 kilohertz to 350 megahertz. And one of the weird things when you're working with this module and you have to calibrate it, one of the calibrations that takes quite a bit of time to do is sweep linearity. And with this module, the sweep linearity is broken down into several 40 megahertz bands. So all these trimmers back here adjust for 40 megahertz segments. So we've got 2, 4, 6, 8, 10 bands that all have to be adjusted. And then over here is the upper limits. But yeah, you have to adjust these starting at I think 160 megahertz and adjust the spacing using a comb generator so that you have the all the marks lined up with the graticule. You adjust that one, and then you go down to the next lowest, to the next 40 megahertz down, to the same thing till you get down to DC. And then start at 160 with the next one up and work all the way up to 350 megahertz. It is a pain if you don't have a comb generator. I tried using one of my signal generators and just changing the frequency every 40 megahertz, and it was a hassle. The rest of this was actually pretty close. I didn't have to mess with any gain controls or any of the attenuator sections, none of it. And you can see I've already pulled out the A5 board because this unit will run just fine without it. And like I said, I double checked these power supplies. This one here I had to adjust just a little bit, and but it was only, about 100 millivolts off. And of course this one here, I just had to touch it up a little bit, but it wasn't enough to mess up the digital board. So I'm not sure what is really wrong with that. I'll just have to guess because I don't have any real way of testing it other than putting it on a riser card that I don't have. So anyhow, yeah, there's lots of adjustments, and I've done this twice, and you can certainly make a career out of adjusting this thing. Well, here's the card that has been giving me all this grief. This here is what's called the data converter card. This is the card that digitizes the waveforms coming out of the Sprctrum Analyzer module and communicates that to the CPU board in the bottom of the unit. Now, I'm not sure what's causing this fault. I originally thought it might be power supply fluctuations or something of that order. But when I was monitoring the power supply, I did not see any large spikes or dips in the power supply voltage. They were pretty rock solid. The one thing I did check, though, is I did check for power supply rail noise. And the 15-volt supplies, the positive, negative 15-volt rails, they were hovering around 200 microvolts. One was, I think the positive rail was around 400 microvolts of noise. But the 5-volt supply rail was hovering around 650 microvolts. And it was jumping up and down a little bit between 650 and 700. The changes were pretty abrupt. And so while that was going on, I was looking at the display, and then all of a sudden the power supply rail noise went up to 800 microvolts, and the fault occurred. So I thought it might have been, well, maybe I got a noisy regulator, and it's the noise level's getting too high. So I pulled the board out and monitored the noise levels, which actually went down to about 475 microvolts. And stayed there. They did not fluctuate at all. And I ran the analyzer for an hour. and ran it through its paces. It was just kind of just stuck as an old analog signal generator, or not a signal generator, but a Sprctrum analyzer. And so, okay, so I turned everything off, put the board back in, and within 2-3 minutes, it happened again. The noise level went up on the power supply rail. It then peaked abruptly about 300 microvolts up, and the fault occurred again. So I'm guessing that whatever component is failing on this is just generating extra noise on the rail as a symptom of the actual fault. It's not the cause of it. But if I was to guess where the fault probably is, I would imagine it's probably this shift register here, because the DACs seem to be working just fine. There's one DAC here, there's another one here, there's another one here, and another one here, and those seem to be okay. But this shift register here basically communicates with the rest of the system, and it may be a fault there. I don't know. I'm just guessing. But without having a logic analyzer, I'm pretty much not even going to bother to try to fix this board. But I did notice when I had it out that this board's been reworked. There is a spot right here. Let's see here. This component here and this component here have been reworked. There's some flux there still. And it is this transistor here. It's Q10 and Q11. Let's see, Q10 here is a pair of JFETs. And this one here, Q11, it's a pair of NPN transistors. And they are part of the circuit that's the track and hold circuit. So, I don't know. I doubt that that's probably the problem. I imagine it's probably somewhere else. But anyway, I think this is going to do it for now. But I looked at these schematics here, and these are, like, here's the track and hold circuit over here where the where those two devices were changed. I'd also think, maybe it might have been the decoding and timing circuit, but I'm not going to waste any more time on this. I'll just end up just buying another parts unit and just cannibalize it and just get the thing working. But for now, it's working just fine in just plain old analog mode, so hey, that'll do. Anyway, catch you guys next time. Thanks for watching.